Alright, let's start by setting up a generic 2 by 2 matrix. We'll give it a name, we'll call it M, so let's go and type that in. Okay, M acts in 2 dimensions, so we'll display a set of axes to show those 2 dimensions. And we're interested in how much it stretches space, so let's plot out all the unit vectors in the space. Then we'll apply M, the matrix, to all of the unit vectors, and we'll get this orange image curve showing how M acts on the unit vectors. We'll sometimes also call it the image of the unit circle. So we're interested in understanding which unit vector S becomes the longest. We're going to call that unit vector the principal right singular vector, and the reason for that name will become apparent later on. And let's choose it here. We could imagine, for example, that the medium is maybe numerically finding it or whatever. It's possible to find. And let's take a look at this vector ms. As expected, it's the longest vector on the image curve. And a very interesting thing, if you look at the tangent vector, you will notice that the tangent appears to be orthogonal to the vector ms itself. And the reason that's interesting is because if you look at other points on the image curve, the tangent at most points isn't orthogonal to the vector. And so that's a special property of this longest vector ms. And that's interesting. It means maybe it's somehow useful for figuring out what the maximal stretching is. So just to state that a little bit more formally, let's make a conjecture. The conjecture is that the tangent to the image curve at ms is orthogonal to that vector ms. And we're going to prove that. The way we're going to prove it is by contradiction. In particular, we're going to suppose the tangent isn't orthogonal to ms and show that that leads to a problem. It leads to a contradiction of assumed facts. So let's go ahead and click and drag the tangent so it's got a component in the ms direction. Here we go. Move it around. We see that the image curve also moves around to remain tangent. And we can see that there's a problem if we look up close at the image curve near ms. Let's move along there. We can see that the vector actually gets longer on the image curve. And the reason why, of course, is that we're moving further out in the direction of ms with the new tangent vector. And that's a problem because by assumption ms was the longest vector on the image curve. But that's no longer true. Our assumption must have been wrong. We've got our desired contradiction, and so the conjecture must have been true. Of course, I've just shown you the basic idea here. We need to fill in some steps to really rigorously prove that, and we'll do that in a moment. But that really is the core idea behind the proof of this conjecture.